I think the best way to imagine software development is just sequential series of bugs. And it's the resolution of these bugs as you go about building something. And in my experience, I'm both a professor, I'm also building software. I'm a business professor, but I'm also building software. In my experience, it's just one bug after the next. And just as you think that something is going to work, something else crashes and something else, there's another problem. And I wish that there was, I mean, there are sort of methodologies to resolve this a little bit, but, if you have experience with this and if you're building on a shoestring budget, which I'm often that's what I'm doing is building on a shoestring budget, is that you'll realize that you'll fix something and inevitably, because the cost of fixing it very robustly, as one would say if it was in a nuclear power plant, for example, and you had to fix it, you have to make sure that everything is robustly checked. But what you'll realize is that there's just sequential bugs, and there's not really a way around it other than just going through a series of very embarrassing moments as you build things, right? Like I think the quintessential depiction of this is Bill Gates when he was introducing Microsoft Windows in 1995. Remember that the whole system crashes right in front of everybody. I believe that's what happened. My memory is absolutely correct. There was always a system that was crashing back in those days, and that's kind of what you have to get used to experiencing. And of course, it's embarrassing. Of course, you don't want it to happen. Um, and you don't really have a good explanation for it, but it just inevitably happens time and time again. And you just resolve that bug and you go on to the next one. You resolve it and you go on to the next one. And you can minimize some of it through better programming, better design, quality control, all of those kind of things. But even the best programs, even the ones that are designed for nuclear power plants, have bugs, and you have to simply just expect it to happen. But hopefully, you expect it to happen within a contained environment with a nuclear power plant. But um, when you're working on and I mean like offline, I'm not saying like running in a system when it's happening. You want to make sure it's very well vetted. But um, what I'm when you're working with a shoestring budget, which is, most entrepreneurship type things, um, you just have to be embarrassed and you have to say, sorry, that broke. We're going to have to keep working at it and keep getting back up and coming up with a contingency plan. And I have done this time and time again where I thought things would work, it breaks, and then um, you simply have to run with it. And you simply have to, often own it, apologize, I just keep going. That is the nature of software development. And if, and in fact, it's the nature of building anything. Because there's a simple problem. We don't have all available information all of the time. This is something that was well understood since the 1950s with Herbert Simon. We don't have all of that information. The only way that we can interact with the world is by having repeated successes and having it win, but then often having sort of failure moments where things just don't work out and there's a negative outcome. And you have to resolve that particular negative outcome and move forward from that, even though that it's embarrassing. And the key thing is dealing with that embarrassment, dealing with those negative feelings in a healthy way, um, and move forward. And one would hope, to the various degree of how catastrophic the bug is, right? Whether it sort of shuts down the entire system or causes a minor delay of something, that is that is that's an important part of how one reacts to it, and how whether it's an embarrassment or, something bigger than that, where it actually is somewhat catastrophic. Um, so, going forward, it's part of the process. One would hope it was easier, but you often cannot understand what what is happening until you actually put it in the market. That's why with clinical testing, for example, drug testing, and with medical devices and medical technology, these are critical systems that they have both, um, you know, preclinical trials and clinical trials and all these kind of things to resolve problems before it gets on the market. But then they also have post-market surveillance, which is looking at how things are actually working in the market. And you often can't anticipate uh, all of the various problems that you're going to experience as you interact. So, with that, happy exploring, happy being embarrassed, and just keep making mistakes. Keep screwing up. That's all it is. Just repeated screw ups time and time again. All right. Take care and have a wonderful day.